Hi, hello, welcome back. In our today's topic, we shall be discussing on current electricity. So the main subtopic will be on flow of current in resistor network. So we have a parallel resistor network and a series resistor network. Basing on this question, the circuit below shows resistor network connected to a 100-volt supply. So you have this diagram where you have a 5 ohm resistor, 6 ohm resistor, 3 ohm resistor that are in parallel, followed by 8 ohm resistor and 7 ohm resistor that are in series. So the first question indicates the direction of flow of current. So current flows from the positive terminal towards the negative terminal, of which the positive terminal is the longer one, so it shall indicate this direction. Then at the junction here, the current flows through the resistors depending with their resistance. Remember, the higher the resistance, the smaller the amount of current flowing through it. So our second question, calculate the effective resistance. So effective resistance here, we can write that effective resistance or R effective is given by resistance in parallel plus resistance in series. So resistance in parallel, from our diagram, the parallel one has the 5 ohm, 6 ohm, and 3 ohm. So you come and say that 1 over 5 plus 1 over 6 plus 1 over 3, as they are the only ones in parallel. Then you find the reciprocal, of which from the calculator, the answer becomes 1.42857 ohms. Then for series, we can say that this was for parallel. So you can say the resistance in series becomes the two. We have the 8 and the 7 ohms. We normally add directly. So it becomes 8 plus 7 to get 15 ohm. However, remember, these two are in series, but then they're also in series with the ones in parallel. So the effective resistance now, the effective resistance R effective becomes the one in series, which is the 15 ohm, plus the one in series, which is 4.2857. So it becomes 16.42857 ohms. So you are through with the first question. Then the second question here is calculate the total current in circuit. Calculate the total current in the circuit. So total current from voltage is equals to current times resistance. So total current R total is equals to the V total over the R total, which means total current is equals to the total voltage over total resistance. So we come now and say that total voltage from our diagram, we have 100 volts. So therefore, it becomes 100 volts divided by the effective resistance here, which is 16.42857. So from our calculator, that becomes 6.0870 amperes. So we are through with the second question. Then our second last question, which is the fourth question, is the ammeter reading for 8 ohm resistor. So remember, we have here an ammeter that is normally connected in series with the circuit. So you have here an ammeter reading. So you want to know the amount of current passing through this resistor, which is the 8 ohm resistor. So you know very well that the 8 ohm resistor is in series with the circuit connection. So therefore, we can say that for 8 ohm resistor, current is the same as the one in series. And in series current is the same, which becomes effective current, which is 6.0870 amperes, as we had found up here. Then the last question is that the voltmeter reading. And remember, you have here a voltmeter reading, which means that we are supposed to find the voltage drop at the 3 ohm resistor. But 3 ohm resistor is in parallel with the other 3. So how do you go about that? So the first thing is to identify the nature of the connection for that resistor. So the resistor is in parallel with the 3. So therefore, we are supposed to find the voltage here, because we know that in parallel, voltage here are the same. So how do you find the voltage? So you say that voltage in parallel is given by total voltage minus voltage in series So therefore, you're supposed to calculate now the voltage in series. So voltage in series is equals to, so voltage in series, we have these two resistors, the 8 ohm resistor and the 7 ohm resistor. So you can sum them up and say that you have a total resistance of 15 from what we had calculated earlier, so that from V is equals to IR, so you now have our total resistance of 15 ohm, then times current that is in series, which is the total current, which is 6.087. So if voltage in series becomes 91.3005 voltage, and now the remaining one will be the voltage in parallel, according to this formula, that voltage in parallel is equals to the effective voltage minus the voltage in series. Our effective voltage here is the main supply, which is the 100 volts. So therefore, in parallel, voltage is given by the 100 minus the one in series, which gives us a remaining voltage of 8.6995 volts. So we are through. Remember, in parallel, voltage is the same. Therefore, the voltage here is also 8 point, the one that we have found. This here is also the same as the one here. So in parallel, voltage is the same, which is the one that we have found here as 8.6995 volts. Then the last question is the current through the 5 ohm resistor. The 5 ohm resistor is the one here in parallel with the others. So to find the current through the 5 ohm resistor, we know that in parallel voltage is the same, and we have already found here the voltage in parallel to be 8.699 volts. So therefore, we shall come and say that for current in 5 ohm resistor, we are using the formula that V is equals to IR. So therefore, I will be given as the voltage over the resistance. Our voltage is the same as the voltage in parallel, which is 8.6995 divided by the resistance in the 5 ohm, which is the 5 ohm resistor, so divided by 5. And from the calculator, the answer becomes 1.7399 amperes. So therefore, if you have any question from the main one, or any comment or anything that you need us to handle, you can simply drop your comment there, but simply or kindly subscribe. Thank you for today. In our next topic, or in our next lesson, we shall be revising effectively on the issue of capacitance. So if you have a question on capacitance, be ready and feel welcomed. Thank you.